Oh, okay. Can you hear me?
Yes, sir.
Yeah, good. Thank you. Last class, for some reason, we started and they couldn't hear me. All right, we're going to start. We are here, February 8th. We're going to start our fourth module. And it's chapter 4, 6, and 7 in the text, arrays and methods and coding techniques. So we'll talk about arrays, start talking about methods, and then we'll do a simple exercise and I'll show you my process for how I decide how to make classes and objects and how to populate those arrays, those classes with attributes and methods. And the idea, of course, is, I'm telling you all about arrays and classes and object-oriented, and then I ask you to do a project, and it's like, okay, great, I have all these pieces. How do I put it together and make a piece of software that works? We're starting to get towards this design process discussion. Also, I was grading the P1 homeworks, the proposals for the projects. I got about a fourth of them done. I'll get more done today. And several people in their inheritance were listing things that just had nothing to do with inheritance. Like, I'm going to do this thing in iterations. At the end of one iteration, I'm going to have some data. I'm going to use that data to initialize the next iteration. And that's so the next iteration inherits the data values from the old iteration. That is not inheritance. Inheritance is not about passing things along in the code execution. It's about what you're doing in the design. Inheritance is where you have a generic class of something, and then you extend that generic class to specific classes. So for example, in the sheep-sheepdog game, we had the generic animal class that was extended to the sheepdog and then extended again to the sheep. So what I'm looking for in your project is somewhere you're going to have a class, let's say you have the Run Away from Zombies game. You've got a generic character, and then you extend it once for the player character. You extend it once for, say, a healthy non-player character, the population, and extend it again for the zombies. Or you have a fighting game with 3 different kinds of weapons. You have a generic weapon, extend it once to weapon number 1, weapon number 2, weapon number 3. I only bring up violent examples because a lot of people seem to like to have combat games. So we're talking about program design when we're talking about inheritance. Okay, let's talk about today's topic. Okay, arrays. And I'm going to start actually talking about data types. And the reason is I want to distinguish between a data type and a data structure. A data type, what is a data type? When I do this face-to-face, we do this as a class discussion. What is a data type? And I try to steer the class towards this definition. I've never seen it in a textbook. I think it's a great definition. I'm biased because I created it or created it over the years with some help of classes. And I think of a data type as a set of values and associated operations. For example, if I say something is an integer, right away I'm telling you the set of values. 0, 1, 2, those are in there. 1.3, 2.5, pi, not in there. So I'm telling you right away a set of values. And also associated operations. What can I do with integers? Well, I can add them, I can multiply them, I can subtract them. Maybe division. It depends on the programming language. But remember, division acts funny with integers. It tends to truncate any decimals. So 3 divided by 5 is 0, not 0.6. But what I really can't do, I know for sure with an integer class, I can't concatenate them, right? You can't concatenate 11 and 12 and get 1, 1, 1, 1, 2. That's an operation associated with strings, not with integers. Similarly with Boolean, Boolean really shows the example because the only values you can have if something is Boolean is true or false. Those are the only two values you can have. And the only operations you can perform are and, or, and not. Even if you want, you can build up other operations out of that. Like you can build an exclusive or up out of and, or, and not. So that definition is a nice, hopefully clarifying definition. I think, one of my beliefs is it's always a good idea to be able to explain what you know, to explicitly know something that you intuitively know. And if you keep that definition in mind, it can help clarify some fuzzy situations, particularly when we start talking about classes. The other thing that data types do is they tell the computer how to handle the data, how much memory space to set aside. So integers are typically 4 bytes or 8 bytes big. Doubles are 8 or 16 bytes big, right? So that it's telling the computer how much storage space is needed. And it also tells the computer how to interpret data. So if you were to look at the raw data in a computer, what are you going to see? You're going to see a bunch of zeros and ones. Well, how do you know if one set of zeros and ones is an integer, one set of zeros and ones is a character, one set of zeros and ones is a Boolean value? How do you know these things? Well, you have to tell the computer, hey, take these zeros and ones and interpret those as an integer. But these over here, interpret these as a Boolean. So the data type is telling the machine how to store and interpret the data. The primitive data types are the ones that are directly supported by the programming language. So virtually all programming languages are going to support integers, and then some form of numeric non-integer like a double or a float, a character, a Boolean, and then a string, which technically is not a data type, but everybody pretends that it is. And then you can start to take these primitive data types and compound them or compose them into more complex things. You guys that came from the C class, you made structs. In this class, we're going to make classes. Classes are actually compound or user-defined data types. And go back to that basic definition. A data type is a set of values and associated operations. That works perfectly for classes. What are the two main parts of the class? What are the two big things that compose a class?
Attributes and methods.
Attributes and methods, right. So there you go. Attributes tell you the values that you can assign to the class. And if you take the word value is actually very rubbery. A value of a class is the value of all of its attributes at any point in time. Like if you just took a snapshot and you looked at all the data values and the attributes, that would be the aggregate value of the class. And then what are the associated operations? The methods. The methods tell you what you can do with a class. So a class is relatively often referred to as a user-defined data type. Now I want to, again, bring this up because I wanted to drill down a little bit into the definitions of data types, but also I want to distinguish between data type and data structure. Data type, just like we've talked about, set of values and associated operations. We often will use that word when we're dealing with just one value, one integer value, one string. But if you have multiple values, you have some decisions to make as to how you're going to store those things in memory. And the storage scheme, the organizational structure of how you store multiple values is called the structure of the data. So a data type is set of values and associated operations. A data structure is a scheme for how you're going to store that data in memory. And different schemes give you different capabilities. There's, depending on how you count them, some 7 to 9 basic data structures. We'll talk about them later in the course. You've heard some of these before, I'm sure. You've heard of an array. You may have heard of a linked list. You may have heard of a stack. You may have heard of a queue. You may have heard of a tree. These are all different ways that you can store data in memory. And each one of those has different characteristics that either helps you or hurts you in performing certain operations. So the data structure that we're going to talk about this week is the array, most basic one. And we'll talk about what's good and bad about it. What's good about it is you get instant access to all of the values. What's bad about it is it's hard to change the size of it. Okay, so data structure, organizational structure. How are you storing this data in memory? If I don't have one integer value, I have instead 1,000 integer values. How do I want to store them? And if you store them in an array, what you're saying is that you're going to store them in contiguous memory locations, one after the other. That's what a true array is. Now, back in the day, back in the 60s and 70s and 80s, when people said they had an array, they really had an array, meaning they had one big long hunk of memory that held all the values one after the other in sequence. That's what an array is. A lot of programming languages today act that way. It still logically acts like an array, but they do cheat. They do store things not exactly all in one memory location after the other. But you should still think of an array that way, because even when the language is hiding that from you, they actually are logically still working with that kind of thinking. So a true array is where you say, I need 100 integers. And by the way, each integer is 4 bytes big. So the machine is going to carve out 400 bytes of memory space and put the 4-byte integers in one after the other. Ding, 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 ding. Now, how do you know how to get a hold of each one of those? Well, the beginning of the array is called the head of the array. Typically, that's the only memory location that the computer needs to keep track of. We'll talk about why in a minute. So normally when you're dealing with an array and you're talking about the quote value of that variable that is representing the array, the value of that variable is just where does this thing start in memory? We know once you go to this memory location, it follows one after the other in contiguous memory locations. Where do I start? Where's the memory location of that thing? All right, so some terminology. An array is made up of elements. So if you had 100 integers, each one is considered an element of the array. And you access those using indices. An index meaning, do you want this one or this one or this one or this one? You have an integer valued index that tells you which one you want. Now, different programming languages count differently. If I had 100 elements in the array in MATLAB, and I wanted to access the first element in the array in MATLAB, what index value would I use? I'm sure there's some MATLAB people in the room. Oh, someone's in chat. Hold on. You would use 1, right? And those of you that came from the C class, if you want to get access to that first element, what index value would you use?
0.
0, right. And here's why. If you said, my array is capital A is what I'm using on the sheet here, capital A, and I said A square bracket 3, what I'm telling the computer is, remember, the computer only knows where the head of the array is, where the beginning is. And what you're telling the array is, go to the head of the array and jump 3 spaces, and then tell me what's there. Well, how do you get to the first one? Go to the head of the array and jump 0 spaces and tell me what's there. That's how you get to the first element of the array. If you jump 3 spaces, you're actually accessing the 4th element in the array. So what MATLAB does, because MATLAB wants to be friendly to people who are not necessarily familiar with a lot of programming, they instead shifted everything by 1. And so when you say, I want 1, MATLAB will go get that first element, and guess how it probably does it? It probably subtracts 1 from whatever index you give it, and then jumps 0 times to give you that first one. Probably how it does it, I don't know. So what that means is, if you had 10 elements in your array, the indices are 0, 1, 2, 3, up to 9, because how do you get to that 10th element? You go to the head, you skip 9, and now you're at the 10th one. So if you had 3 elements in the array, the only indices you can use are 0, 1, and 2. If you have 100, it would be from 0 to 99. If you have some generic array with n elements in it, it's 0 to n minus 1. Those are the legal arrays you can use. Array indices you can use. If you use something less than 0, -1, you're going to get an error. If you had 100 elements in the array and you actually asked for the 100th element, a square bracket 100, that's too big because 99 is the biggest legal value you can put in there. So if you said A100, you're getting an error. And the error is called array out of bounds exception. That's what it'll say on your screen. Array out of bounds exception. Well, it's out of bounds. The bounds are 0 to 99. You asked for -1 or you asked for 100, that's out of bounds. This is where you can have problems with loops. Fortunately, Java gives you some help in this regard. So, remember that we said when we discussed loops, it's those end conditions that always cause trouble. When do you start and when do you stop? That's where you're going to have trouble most of the time. And that's why. Usually it has to do with aligning index values to an array. Okay, so Java refers to the first element in the array as 0 because you go to the head and you jump or skip 0 elements. And it refers to the last one as n minus 1. So again, if you had 100 elements in the array, it would be 99. A square bracket 99, go to the head of the array, skip the first 99, and then tell me what's there. Java provides arrays to you as an object. You do not need to import it. It gives you the array as an object. Now, right off the bat, tell me again, what are the 2 big components of a class?
Attributes and methods.
Attributes and methods, that's right. Well, since they're providing the Java array class to you, guess what? There are attributes and methods. So they're going to give you some information about the array, and then they're going to give you methods to work with the array. And quite frankly, I don't know the methods. I rarely use them. I'm sure, I will guarantee that sort is a predefined method. So you can put values in an array called the sort method, and it will sort them from high to low or low to high. We'd have to look at the Oracle help pages to see all the methods there. Okay. So the most useful attribute, though, is the length. You can automatically know the length of the array by using array name dot length. And now you know the length of the array. And the reason that's useful is when you're doing your for loops, you always know when to terminate the for loop. Array length, array dot length. You can declare arrays. I'm here. You declare them by using the primitive data type that you're interested in, square bracket, and then the name that you want to, or name the array. My favorite array, whatever. I often in examples will just use little a for array. So here, int square bracket array is saying to the Java virtual machine, hey, I'm going to create an array of integers. Have I created it yet? I've declared it, but have I created it yet?
Could you repeat the question, sir?
Sure. in this line that's highlighted on your screen right now, int square bracket integer array, I have declared this array. Have I created the array yet? No.
No, you have not.
I have not. And why do you know that? You know that because I told you that arrays are objects, and the only time you get a new object is when you see the new keyword. And since the new keyword is not there, you have not created that array. You've declared it. And then down here, I say, okay, I declared it earlier. Now I'm actually going to make it. Integer array equals new int 20. And that's how you declare and create arrays. When you say new, you're saying, give me a new array. And what is it that I want to get? I want an integer array that has 20 elements in it. And notice the square brackets instead of the parentheses here. It's fairly normal to do this trick. You declare it up here, but you don't create it, and then you create it later on. Why would you do that? Well, usually you don't know how big you want the array to be yet. And if you don't know how big you want the array to be, you have to wait before you actually make the object for that array. So this is a fairly common thing to do. But what value is this? Integer array. Let's see. Well, remember what I said. What's the only thing that the computer knows about the array, really? It knows where the head is. It knows where it begins in memory. So that integer array variable name, it doesn't store all the values of the integer. It's really just storing the location of the beginning. It's of the head of the array. It's storing the memory location of the head of the array. Now, whenever you create an attribute or a variable in Java, they will initialize the values for you. So for example, if you create an integer attribute, but you don't put a value in, Java will assign a value of 0 to that integer. And if you create a double, it will assign a value of 0 to that double. Here, integer array, remember, its job is to have, its value is going to be the memory location where the head of the array is. And since we haven't assigned anything to it, it's going to give an initial value of null. Once I get here and I say, oh, give me actually make the array now, make the array object. That's what the new keyword said, right? Make me an object. Make me an object. It's an integer array of 20 elements. And now what happens is the value that's really associated with integer array here is just where in memory did you put that thing? That's the value of it. So initially the value is null. And some of you are going to experience throughout the semester an error message that says null pointer exception. And you're going to say, hey, Dr. Garfield, I was looking, trying to run my code. I'm getting this null pointer exception. I'm getting an error. And I'm trying to access an array. And what's happening is you declared the array. You forgot to create the object, right? Create the array object. So you've declared the array has a null value, but you never created the actual array. So you have a null pointer exception. This happens with arrays. This can happen with objects. And as we'll see later on, we can make arrays of objects and it can happen there too. So that's what that means. Whenever you get a null pointer exception as an error code, it means that you're trying to refer to something that you have not yet created. And we'll do examples of that. Okay. You can do it all in one line. Here I'm saying double square bracket, another array equals new double 1000. Okay, what am I doing? I'm declaring an array of doubles. I named it another array. And I actually created the object at the same time. I created the array at the same time. Equals new, that's how you know I made the object. And now since it's a double, it's double square bracket. And I say, how big do I want it to be? I want it to be 1000 elements. You can create arrays of classes that you created. So earlier, a couple of weeks ago, we created that circle object class. And now I want to make an array of circles. So I do circle object, square bracket, all my circles equals new circle object 15. That would give me 15 circles. We'll talk about it later. It's slightly more complicated than that, but basically it's going to give me 15 circles. This is a common thing to do. You guys have, you know, for example, in the sheepdog game that I had, I would create an array of sheep. I would create the, you know, sheep, square bracket, all my sheep equals new sheep, square bracket 3, because I want 3 sheep in that game. You got the zombie game? Create an array of zombies. Several years ago, you know, there was an old game called, what was it called? Missile Defense or something like that, where these missiles were coming in and, you know, you had a city on the bottom, and as long as your city was still existing, then you could play, but these missiles kept coming in and you had to try to destroy them before they blew up your city. And he created an array of missiles, missile objects, I should say. So a lot of you guys are going to end up doing this kind of thing. Okay, so the declaration reserves the space to keep track of where the head of the array is, and then the creation with the new keyword actually lays out the memory to hold all the array elements. Okay, here's a simple example. Now, this is a complete class, public class array example. It's a complete class, open curly bracket, close curly bracket down at the bottom. How many attributes are in this class? Kent, are you answering this question? I didn't see when it popped up in chat. Yes, okay, 0 attributes. Why? Because remember, attributes are created outside of all the methods. So there's nothing created outside of all the methods here. And then we have public static void main string args. And then inside I actually create a variable, double example array, and my variable is an array of doubles. I declare it here, but I do not create it. Then I say example array equals new double 100. Now I've declared the array with 100 elements. And what's happening when I say the new keyword, new double square 100, what the Java virtual machine is, it's going to go find some memory somewhere where it can put 100 doubles in a row. It's going to remember where the head of that array is, and then it's going to assign that value to example array. So if we try to look at example array, we're going to get some crazy stuff because all we're getting is a memory address of where the array begins. And now I want to actually put values in the array. So the normal way to do this is to loop through the array. And all I'm doing is for each element here, I'm putting in a 100 times math.random. I'm just filling it up with random values. Random values are your friends, especially when you're testing your software and you need to create some data really quickly. Just make a bunch of random data. Math.random. Oh, what's that? Random. Every programming language these days gives you a random function. They all, virtually all, will behave the same. The random function will return a value, a double between 0 and 1. Evenly distributed, not a bell curve, evenly distributed. So you're just as likely to get a low number as a high number as a middle number. All programming languages have some mechanism by which they will give you a random value. And where's this one? It's in the math class, so math.random. Now remember, we used math.pi before when we were doing the area of a circle and perimeter of a circle. The math class is a predefined class that you all always have access to. You don't need to import it. The people who created Java assumed that enough people would need to use the math class that they weren't going to make you import it. It's always available to you. Just like the system class is always available to you, right? How do you print things out? System.out.println. Well, the system class is always available to you. So these classes that the assumption is virtually everybody is going to use, you don't have to import. How do you know if you need to import a class? Well, first of all, if you try to use it and you get an error, then you know. But you know, that's what tutorials are for, and that's what documentation is for, and that's what experience is for. And we'll have plenty of examples later on as you need to import stuff. When we get into graphics, that's when you need to import a lot of graphical elements. So let's look at this for loop for a second. The way it's built is, let's say, let's see, I had 100 elements in that array, right? So it's for int I equals 0. Leave that blank for a second. I plus plus, in fact, I'm going to leave this blank too. I equals something. And then we did array. I'm using a different name. I equals, and then make random value. Okay. I'm just being lazy and not typing everything out. Okay, so we want every element in the array. We have 100 elements in the array. So we have every element in the array we want to have filled with a random value. And how do I get access to the first one? In other words, when I say a sub I the very first time, how do I get access to that first element in the array? What value should I have?
It's whatever you declared I to be in the array. I mean, in the loop.
Right, right. So what value though? Well, how do I get to the first element in the array?
Would be 0.
It'd be 0. That's why you start out at I equals 0. What we're saying is go to the head of the array and don't skip anybody. Make that first one a random value. And we're going to end, what's the highest value that I is going to take on? We have 100 elements in the array, so it's going to go from 0 to what?
99.
99. Okay, so that's what that for loop will look like, and that will fill up all 100 elements in that array. Now, as you know, hard coding things like this is generally a really bad idea. So if I change the size of the array, I have to remember to go back in here and change 99 to something else. I'll always start at 0 because I always want to start at the beginning of the array, and that's always 0. But it's this end condition that's going to get us 99. So if I change the size of the array, I'd have to go back and change this. Fortunately, though, because the array is a object and it has an attribute and it has a really nice attribute called length, I can just reference the attribute a.length. So if I said to the Java virtual machine, give me an array of 100 elements, length is going to be set to be equal to 100. So this will work. Oh, I said 99 before. That was wrong. Why didn't you guys yell at me? 99 is the last legal value, so it's going to be strictly less than 100, right? Because 99 is the last integer value before 100. And so rather than having to hard code this stuff or have temporary variables that help us out, you can just use whatever the name of your array is, .length. Very convenient. And always correct. No matter how many times you change the length of your array or create new arrays that have different lengths to them, your loops will always be correct. You should still test them, but they will always be correct. So that's why you see this construct here. For int I equals 0, I less than example array dot length, I plus plus. Almost all your for loops are going to look that way. Because usually what are you doing with a for loop? You're walking through an array and doing something to each array element. So how do you find the first element? It's the 0th element, I equals 0. How do you go to the next one? I plus plus, right? Keep incrementing I. And how do you know when you're done? Well, you always do this as long as I is less than the length. If the length is 100, less than the length will give you 99, which is the right last value you need for I. If it's 150, the last I value will be 149, which is the right one if you do I less than, strictly less than, not less than or equal to. Strictly less than example array dot length. It always works. It's convenient. Now, if it doesn't work, right? If you still have something in there that's wonky, and you know things do go wrong, you're going to get these array out of bounds exception. If for some reason, you know, let's say we have our array of 100, that means any value of I between 0 and 99 is perfectly fine. But if I try to set I equal to 100 and then access that array element, I'm going to get an error, an array out of bounds error. 0 to 99 is in bounds. 100 is out of bounds. If things go really wrong, I might try to access the -1 element, also out of bounds. So this simple example gives you a template basically to walk through an array. And what we'll do on Wednesday is go through, I put the code example up already, simple code example about how to create and manipulate an array. And what we'll do on Wednesday is I want to not just show you that code, but build that code out from scratch to give you an idea of my process for how I design, create, and program objects, classes that work together to get you working, beginning on, hey, how do I get my project done? How do I do this stuff, right? How do you design software? So we're going to start talking about process a little bit on Wednesday as we go through that example. And there's more process discussions in the project discussions each week. Okay, so let's start talking about methods. Remember, classes are composed, again, attributes and methods. Attributes, their job is to describe the state of an object at any point in time. If you put values in all those attributes and took a snapshot, that's the state of the object at that point in time. And methods, their job is to generally modify those attribute values or report out those attribute values. For example, you might be wondering right now if your car is locked. If you weren't before, you might be now. Well, if the car was a software object, you should be able to ask it, are you locked? Give me the value of the locked attribute. Is it true or false? Or you might wonder, how much gas you have. Okay, if the car was a software object, you should be able to ask it, how much gas do you have? So methods, sometimes all they do is report out the values of the attributes so that other objects know what's going on. But sometimes they modify them. Again, for the car, you go to the gas station and fill it up. If that car was a software model, you would have a filler up method that takes the gas level and puts it to the maximum value. You have to, when you're defining methods, do visibility, static, return type, name, input parameters. We know this already. Let me make a method here. Our old friend. And then we do stuff in here. This is the visibility modifier, right? Public, everybody can use it. Then we make it static. It doesn't have a return type. It doesn't have a return statement, so its return type is void. And then its name is main. And as an input parameter, which we've not used yet, we are allowed to put in a string of an array of strings. Main can accept an array of strings. By the way, the fact that we haven't used that, isn't that a problem? Aren't we required to give it an array of strings? How many of you guys can't sleep at night because, oh my God, we've never given main an array of strings, but it keeps working? Here's what you're giving it. You're giving it an empty array. So you've met the requirement. An empty array is still an array. Nothing is something. Yeah, I sleep fine. Yeah, that's a problem. We're all sleeping fine. We're not asking good questions. So that's what's happening. An empty string is still a string. We're giving it a null. I'm sorry, an empty string is still a string and an empty array is still an array. We're basically giving it a null array. And as long as we don't ever ask it to look at the input arguments, that's fine. That's fine. And so we'll see examples later on in the semester. Yeah, it is. It is something from the Java library, but remember, it's requiring an array and we're not giving it one. That's okay, because what did we say? We can declare an array. Already that array has a value of null. And as long as we never try to look at the array, then it's fine, because we never asked to go to that null memory location. Okay, so we'll get this. S for stupid class. Okay. Now, I've mentioned before, attributes are classes are made up of attributes and methods, and so here I have 3 attributes. Why do you think I'm correct? Why do you think I have 3 attributes here? Or am I wrong? If I'm wrong, you need to let me know I'm wrong.
They're attributes as they're not declared in the main function.
Right. They're declared outside of any method. No method, they're not declared inside of any method. Okay, so now I'm going to have, for every attribute, you should have something that'll called a setter and a getter, right? So we have a setter that will let an external entity set the value. And for a getter, you would have an external entity receive that value. Let's do the getter first. So remember, it's got to be visibility, static or non-static, return type, name, parameters, and then you actually do the method. Okay, so we're going to create a method. All it does is, let's do it for the x attribute. All it does is it returns the value of the x attribute to whoever asks for it. And it returns it, to another class. Another class is going to ask, hey, what's the value of your x attribute? And this method is going to give it back. Okay, is going to return, tell them that value. So first of all, visibility. Basically, we only have public or private to deal with. Oh my gosh, I'm so embarrassed. All your attributes should be private. Okay, now, should this method be public or private? Remember, we want external entities to ask the question. What does that tell you? Public. Public so that external entities ask the question. Should it be static or non-static? Exactly, yeah, good. Should it be static or non-static? Non-static. Now, I'm going to make it static for a minute, and then I'm going to yell at myself, okay? And then return type. Does it actually return a value? Does it actually give something back to somebody who asked for it? Remember, its job is to give back the X value. So is it giving you, yeah, right, we're doing a getter. Yeah, a getter. So it returns the X value. Now, what data type is the X value? It's an int. And then what's its name? Now you can do it this way or you can do it that way. It doesn't matter. That's personal style for me. And whoops. It doesn't need any information. And all it does is that. That's it. Now, I told you I was going to yell about this later. You should not do this. Do not do this. When should you make a method static?
When it's not going to be changing.
It's not changing, right? And how often does that happen?
It depends on what you're trying to do.
We're going to put a tight restriction on this. Main is static. Main is static. Everybody else, not static. Don't make static methods. If you make static methods outside of main, 99.999% of the time, you've got a problem, and what you're doing is covering up the problem. Now, having said that, I think in your lab they use static methods, and I know in the textbook they use static methods, and they kind of sort of have to, or at least they think they have to do some of the early work. I have a disagreement with the author there. And I know our lab work came from the early textbook stuff. So you're going to see static methods in the class, and I'm just telling you, it's an excuse to make things work before you have the tools to do it properly. Do not make methods static. If you see a friend in class and they say, I couldn't get my program to work, but I made this method static, and now it works fine, your response should be, this is not fine. You have a problem. Now let's go fix it. So it's got a public and a return type and a doesn't need a value. Now wait a minute. Wait a minute. It says return X, but how does it even know what X is? Because we didn't declare X inside of the method, right? X is declared way up here as an attribute. So how does this thing have access to X? Here's the trick. All the methods in a class have access to all the attributes in that class. And that's why you create things as attributes, not values. Number one, they're more permanent. Remember, you're trying to describe the state of an object. So if you want to take a player character in a game and you want to put them here, you set their X location and Y location values here. And they stay there if it's attributes. If it's a method, as soon as you run the method, X location, Y location here, the method's done, that the X location, Y location is obliterated from memory. So you don't have permanence there. Attributes are permanent, and they're going to describe the state of that character, right? Where are they? They're right here. So all methods have access to all attributes. Now we'll do what's called a setter, where we allow an external entity to set the value of X. Now, I'm going to leave this here, and we call it set X. And because the external entity needs to set the value of X, we're going to say X is equal to something, but how do we know what that something is? Well, the external entity will tell us. Let's see, X is an integer, so we're going to put in we're going to use that as an input parameter. They're going to tell us set X to 25, set X to whatever. And all we do is this. And that's all this thing needs to do. Now, what return type should I have? Is it returning anything back? Is it giving anything back to the person who called it, to the class that called it? No, so we use void. Now, I made a setter. These are called setters and getters. Okay, technically they're called accessors and mutators, but we call them setters and getters. We made a public method to set X. We made a public method to get X. What do these do? the public method setX allows an external entity to set the value of X, and the getX allows an external entity to get the value of X. So we would do this for X, we would do this for Y, we would do this for Z. We would have a total of 6 methods here. These are just the housekeeping methods. Setters and getters for your attributes are just housekeeping stuff. We haven't actually done any interesting things with the class yet. So the idea here is, you go in a minute. The idea here is you would have, 6 methods. That's kind of tedious writing. If you had 20 attributes, you would have 40 methods. That's tedious to write. Developer toolkits like Eclipse have wizards by which once you create all your attributes, you open the wizard, click, 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 give me all these setters, give me all these getters, and it creates them automatically for you. So that's one advantage to using those toolkits. The last thing before and then I'll let you go. I keep saying make all your attributes private. Very rarely should you make them public. Make them private. But what the heck, Garfield? You make them private, but then you tell the public about them anyway. Virtually all your attributes should be private. All your methods should be public. Well, the reason is that's okay is if you don't want anyone to know what X is, just don't make that getter. And by the way, you don't have to accept any old crazy value that they give you because you are creating the software that sets the value of X. You can check for rationality. You can make sure that you don't have aircraft at negative 10,000 feet and ships at positive 10,000 feet. So you have you're still controlling your data. Remember, the number one thing of object-oriented stuff, control your data. Okay, I'm running late. Apologies. I'm going to let you guys go. If you have questions, ask them on Wednesday, and you can always ask me in Canvas messaging. Thank you for being here.